Today we are going to discuss working rule model questions on integral calculus. Suppose that the integral function of the type integration of 1 by a plus b cos x dx or integral 1 by a plus b sin x dx or integral 1 by a cos x plus b sin x plus c into dx. Such type of problems can be solvable by substituting tan x by 2, which is equal to t. When you write tan x by 2 equal to t, x by 2 written as tan inverse of t and x equal to 2 times of tan inverse of t, and dx become 2 divided by 1 plus t square dt. And here in this case, the value of cos x and sin x can be written as 1 minus t square. Why? Because cos x is nothing but 1 minus tan square x by 1 plus tan square x by 2. So that 1 minus tan square x by 2 here, 1 minus t square, and it is 1 plus t square. Sin x, 2 tan theta by 2. So 2t by 1 plus t square you will get. Let us discuss. This is the working rule. Let us discuss a problem based on it. Suppose if you have the question integral 1 divided by 5 plus 4 cos x dx. This is the question. By the working rule, you have to write tan x by 2 equal to t and cos x value 1 minus t square by 1 plus t square, and the value of dx, that is 2 dt divided by 1 plus t square. Just by previous discussion, cos x dx and the substitution tan x by 2 equal to t. Yes, when you substitute tan x by 2 equal to t, you will get integral 1 by 5 plus 4 cos x written as 1 minus t square by 1 plus t square, and dx is 2 dt by 1 plus t square. So that you will get 1 plus t square whole divided by 5 plus 5t square plus 4 minus 4t square, 2 dt divided by 1 plus t square. 1 plus t square, 1 plus t square gets cancelled. Now you will get integral 2 dt divided by, this is 9 minus t square you will get. Dt by 9 minus t square written as dt by 3 square minus t square. It is like integral 1 by a square minus x square dx. That is, the result is 1 by 2a log modulus a plus x divided by a minus x. Using this formula, you can write here 1 by 2 into 3 log of 3 plus t divided by 3 minus t. 2 gets cancelled and you will get 1 by 3 log of 3 plus tan x by 2 divided by 3 minus tan x by 2 plus c. This is the process to find integral values of the functions in the form of 1 by a plus b cos x, 1 by a plus b sin x model. And in case, if you have a plus b cos 2x, a plus b sin 2x, what happens? Observe. Suppose the question is integral 1 by 4 plus 5 sin 2x dx. when you have multiple angle, in that case, you have to write tan x equal to t and x equal to tan inverse of t, and the value of dx become 1 by 1 plus t square dt. Now integral 4 plus 5 times of sin 2x written as 2 tan x by 1 plus tan square x, and dx clearly dt by 1 plus t square in this case. On simplification, it become 1 plus t square divided by 4 plus 4t square plus 10t, and here dt by 1 plus t square. 1 plus t square, 1 plus t square gets cancelled, and you will get dt divided by 4t square plus 10t plus 4. And here, in the denominator part, if you take 2 common, you will get dt divided by 2t square plus 5t plus 2. When you take 2 common, it is t square plus 5 by 2 of t plus 1. Next, t square plus 2 into t into 5 by 4 plus 25 by 16 minus 25 by 16 plus 1 you have to write. And here, these 3 terms in a perfect square form, t plus 5 by 4 whole square. Next, here it is minus 9 by 16 you will get. Therefore, 1 by 2 integral dt by this quadratic expression can be written as 1 by 2 outside, and this is t plus 5 by 4 whole square minus 3 by 4 whole square it is. This is 1 by 4, 1 by x square minus a square, that is 1 by a, 1 by 2a log modulus. I am going to write 1 by 2a is nothing but 1 by 2 into 3 by 4 log modulus x minus a divided by x plus a you will get. Therefore, here 1 by 6 log modulus 4t plus 2 divided by 4t plus 8 you will get plus c. Neglecting 2, you will get 1 by 6 log modulus 2t plus 1 divided by 2t plus 4 plus c, where t is nothing but tan x. This is the process to find such type of integrals. Next, suppose that integrals are of the form integral dx by a cos square x plus b sin square x model, or integral dx by a cos square x plus b, or integral dx by a sin square x plus b, or integral dx by a of sin x into cos x plus b of sin square x plus c of cos square x. Such type of problems can easily solvable by dividing each and every term with cos square x. For example, the question is integral 1 by cos square x plus 5 sin square x dx. This is the question. If you have cos square x plus 5 sin square x, then divide each and every term with cos square x. You will get 1 by cos square x divided by 1 plus 5 sin square x by cos square x into dx. 1 by cos square x is secant square x. Next, here it is 1 plus 5 tan square x dx. Now put tan x equal to t. Then you will get secant square x dx is dt. It become integral dt divided by 1 square plus root 5t whole square. 1 by 1 plus x square nothing but tan inverse of x. Therefore, tan inverse of root 5t plus c is the answer. Therefore, you will get tan inverse of root 5 into t is nothing but here in this case tan x, right? So this is the answer. We will discuss another question. Suppose integral a into e power x plus b into e power minus x divided by c into e power x plus d into e power minus x dx is the question. In this case, and also suppose the questions are of the form integral a sin x plus b cos x divided by c sin x plus d cos x into dx. Such type of problems can easily solvable by the working rule. Numerator part equal to a into d by dx of denominator part plus b into denominator part. This is the suitable substitution working rule for these type of questions. For example, if you select integral function in exponential form, suppose if you have e power x plus 2 times of e power minus x divided by 3 e power x minus e power minus x, suppose if you have, then here in this case, this is integration of numerator divided by denominator dx, and you have to consider numerator as a into d by dx of denominator plus b into denominator whole divided by denominator into dx. So this is equal to a outside integral f dash x by f of x, that is log modulus denominator, next plus b into denominator part gets cancelled, and only for integration for b, that gives bx plus c. This is the result. And here just we need to find the value of a and b, that's all. And to get the value of a and b, just write numerator first. Numerator e power x plus 2 times of e power minus x, which is equal to a into differentiation of denominator 3 into e power x, 3 into e power x, next e power minus x derivative minus of e power minus x, so that you will get plus e power minus x, next plus b into denominator part, that is 3 into e power x minus of e power minus x. When you take e power x common, you will get 3a plus 3b equal to 1. When you take e power minus x common, a minus b equal to 2. Here, if you multiply this with 3, then what happens? 3a minus 3b equal to 6. Solving these two equations, 3b gets cancelled, 6a become 7, adding these two. A become 7 by 6. Next, when the value of a is 7 by 6, 3 into 7 by 6 plus 3 into b equal to 1. 3 1 ja, 3 2 ja. So 3b become 1 minus 7 by 2. 3b is minus 5 by 2. Therefore, the value of b equal minus 5 by 6. So that here you have to write capital A 7 by 6 log of denominator part, c into e power, this is 3 into e power x minus of e power minus x. Denominator, here it is minus sign. Let us wait. Here, it should be minus sign, right? Let me calculate again. Here it is. Numerator, nothing but e power x plus 2 times of e power minus x, which is equal to a into differentiation of denominator. 3 into e power x as it is. Yes, it is plus e power minus x. Next, plus b into denominator part. 3 e power x minus of e power minus x. Comparing e power x components, 3a plus 3b equal to 1. Next, a minus b, which is 2. Multiply with 3, you will get 3a minus 3b equal to 6. Solving these two equations, 6a equal to 7, a equal to 7 by 6. Yes, it is. Next, 3b written as 3a minus 6. Therefore, b equal to a minus 2. Therefore, the value of b equal to 7 by 6 minus 2. b equal to 7 minus 12 divided by 6. Therefore, the value of b equal to minus 5 by 6 only. Yes, here you have tried the value of a and b. That is your answer. When you have constant here, if suppose there is another constant e and here f, in that case, here you have to write plus c. That is the process to find integral values. Next, we will discuss the problems based on partial fractions. Suppose the question is integral 1 divided by x minus 1 into x minus 2 into x minus 3 into dx if you have. In this case, first write something by x minus 1 into dx plus something by x minus 2 into dx. Next, plus something by x minus 3 into dx. To get the constant upon x minus a, just to close x minus 1 and put the value of x equal to 1 in the remaining part. 1 divided by 1 minus 2 minus 1, 1 minus 3 minus 2. So minus 1 minus 2 become 2 it is. Next, put x equal to 2 in 1 by x minus 1 and x minus 3. When you write x equal to 2, 2 minus 1, 1, 2 minus 3 minus 1, and hence you will get minus 1. Next, put x equal to 3 in 1 by x minus 1 and x minus 2. In the remaining part, you have to substitute 1 by 3 minus 1, 2, 3 minus 2, 1, and hence you will get 1 by 2 here. If you simplify this, again you will get the same integral function. So 1 by 2 outside, integral 1 by x minus 1 dx, minus 1 outside, integral 1 by x minus 2 into dx. Next 1 by 2 outside, integral 1 by x minus 3 into dx. Now, 1 by 2, it is log modulus x minus 1. Next minus log modulus x minus 2. Next plus 1 by 2, log modulus x minus 3 plus c. This is the result. Whenever the denominator part has non-repeated linear factors, then you have to proceed like this. First, write x equal to 1 in the remaining part of the integral function. Then you will get constant here. To get the constant upon x minus 2, close x minus 2, and in the remaining part, substitute the value of x equal to, that gives another constant. Same way, proceed to the other, you will get partial fractions. Next, suppose the question is integral 1 divided by x square minus a square into x square minus b square into dx. Suppose if you have, then you can easily separate into two parts like this: x square by a square first, and then x square minus b square next, dx. To get the constant upon x square minus a square, first to close x square minus a square, nothing but x square equal to a square. Substitute in remaining part. You will get 1 by a square minus b square. Next, to get the constant upon x square minus b square, put x square equal to b square in the other. You will get 1 by b square minus a square. If you take common 1 by a square minus b square, then integral 1 by x square minus a square into dx minus integral 1 by x square minus b square into dx you will get. Therefore, 1 by a square minus b square is the constant here. Next, 1 by x square minus a square integration 1 by 2a log modulus x minus a by x plus a. Next, minus 1 by 2b log modulus x minus b divided by x plus b. This is the result. Next, we go for another. Suppose integral 1 by x square plus 1 multiplied by x into dx. One linear factor and the other irreducible quadratic factor. In this case, first by partial fractions, we have to consider 1 by x square plus 1 into x as ax plus b divided by x square plus 1 and then c divided by x. 1 equal to ax plus b of x, next plus c of x square plus 1. 1 equal to a into x square plus b into x plus c into x square plus c you will get. Comparing coefficient of x square, a plus c is 0 and coefficient of x 0, constant is 1. When you write c value, this is c into x square plus 1. This is ax plus b into x. Yes. Coefficient of x square, a plus c 0. When you write c value 1, you will get a value minus 1, b value 0, c value 1. Therefore, we get integral ax nothing but minus x plus b divided by x square plus 1 dx. Next plus integral c is nothing but 1 divided by x dx. Therefore, minus outside, integral x by x square plus 1 dx plus integral 1 by x dx. If you multiply with 2, and divide with 2. What happens? Minus 1 by 2. F dash x by f of x is log modulus x square plus 1. Next, integral 1 by x is log modulus x plus c. This is the result. So, whenever denominator part has irreducible quadratic factor, in that case, upon the quadratic expression, you have to select a linear form ax plus b. And if you have linear factor, upon that, you have to consider a constant in this way. This is the process to find integrals when proper fractions are given. Next, we will discuss reduction formula. Integral sin x whole power n dx, integral cos x whole power n dx. Next, integral tan x whole power n dx, integral cot x whole power n dx, integral secant x whole power n dx, and then you have integral cosecant x whole power n. Reduction formula is nothing but reducing the action. Reduction is nothing but when you have sin x whole power n, you can easily find integration of sin x and sin square x, sin cube up to sin cube x. We can find by using trigonometric formulas, right? When you have powers more than 3, nothing but sin power 4, sin power 5, such type of questions are very difficult by using trigonometric formulae. So that for which you have some reduction formulas. The first one is minus sin x power n minus 1 into cos x divided by n plus n minus 1 by n I of n minus 2 is the formula. Next, cos x whole power n, that is cos x power n minus 1 into sin x divided by n plus n minus 1 by n into in minus 2. Next, tan x power n formula. Tan x power n minus 1 divided by n minus 1 plus minus in minus 2. Minus I of n minus 2 it is. This is in. This is also, since index n, consider it as in, integral for n power of trigonometric function, right? And cot x whole power n, for which we'll get minus cot x power n minus 1 by n minus 1 minus in minus 2. Secant, all of them positive. You will get secant x whole to the power of n minus 2 into cosecant x divided by n minus 1 plus n minus 2 by n minus 1 into I of n minus 2. Next, cosecant minus cosecant x power n minus 2 into secant x divided by n minus 1 plus n minus 2 by n minus 1 into in minus 2. These are the reduction formulae for trigonometric functions. Next. And you have reduction formula for integration of log x whole power n dx also. These standard results you have to remember. And one more standard result. Integration of log x whole power n dx. Suppose this is the question. Here you have to write integral log x whole power n into 1 into dx. This is u and this is v. First u log x whole power n, integral v dx, nothing but integral 1 dx minus integral derivative of u n into log x power n minus 1, log x derivative 1 by x. Next integral v dx and then whole dx. X into log x whole power n minus n integral log x power n minus 1 1 by x into dx. X gets cancelled. Therefore, in equal to x into log x whole power n minus n into, this is in minus 1. So this is the reduction formula for integration of log x whole power n dx. Suppose, for example, integration of tan x whole power 5 dx is given. You have to use the formula in equal to tan x power n minus 1 by n minus 1 minus in minus 2. This formula we need to use. See here. Here, the value of n equal to 5. So that if you substitute in this, then you will get first tan power 4x divided by 4 minus I3 you will get. Next. Again, you have to find I3. This is tan power 4x by 4 minus sign outside. I3 written as tan x whole square divided by 2 minus I1 it is. Next, tan x whole power 4 by 4 minus tan square x divided by 2 plus I1 you will get. Tan x power 4 by 4 minus tan x whole square by 2 plus I1 is nothing but integration of tan x power 1 dx. That is tan x power 4 by 4 minus tan x whole square by 2 plus integration of tan x is log modulus secant x plus c. So this is the process to find tan x higher powers of trigonometric functions integrals. Let us discuss some other questions. Suppose the question is I is given as integral e power tan inverse of x inside the bracket 1 plus x square plus x whole divided by 1 plus x square into dx. This is the question. Option A is given as x into e power tan inverse of x plus c. Option B, x square into e power tan inverse of x plus c. Option C given as 1 by x into e power tan inverse of x plus c, and option D is none of these. See here. First, let us suppose that if you select first option, then what happens? Observe, x into e power tan inverse of x, I am going to differentiate. I am going to differentiate first option. This is u. V dash nothing but e power tan inverse of x derivative e power tan inverse of x, and tan inverse of x derivative 1 by 1 plus x square. Next, v is nothing but e power tan inverse of x and then 1. On simplification, it becomes e power tan inverse of x. Next, x by 1 plus x square plus 1. Yes, here it is. This is e power tan inverse of x. Next, x plus x square plus 1 by 1 plus x square you can write. So that you got integral function. By differentiating first option, we got integral function. Integration is reverse process of differentiation, and hence option A is right answer. Let us discuss another question. The question is based on reduction formulae, but in terms of tan is given. Secant x whole power 4 into dx is option A, tan x plus tan square x divided by 3 plus c. Option B given as tan x plus tan cube x divided by x divided by 3 plus c. And option C given as tan x plus tan x whole power 4 by 3 plus c. Option D given as tan x power 4 by 4 plus c. Here, secant power 4x dx. Actually, you have reduction formula in terms of secant power 4, but here the solution is in terms of secant and cosecant, right? Here it is not cosecant, here it is tan. And here it is cot. Right. Secant x whole power n is, you have this reduction formula, but this is not worked out in this question. Why? Because the solutions are entirely in terms of tan. So that I am going to change it as secant square x into secant square x. I am going to write first secant power 4 written as secant square x into secant square x dx. Secant square x is 1 plus tan square x multiple secant square x dx. Now, when you write tan x equal to t, secant square x dx become dt. One integral value t square integral value t cube by 3. So that the value of t clearly tan x. Next, tan x whole cube divided by 3 plus c. Therefore, option B is right answer. Next, we go for another question. The question is, integration of e power x multiplied by 1 plus sin x divided by 1 plus cos x dx. This is the question. Option A given by e power x divided by 1 plus cos x. Option B, e power x into cot x by 2. Option C, plus C. Option C given as e power x into tan x by 2 plus C. And option D, none of these. Right. 1 plus sin x by 1 plus cos x you have. One plus cos x I am going to change. First 1 plus sin x written as 2 sin x by 2 cos x by 2 divided by 1 plus cos theta nothing but 2 cos square theta by 2. So here I am going to write 2 cos x by 2 cos x by 2 into dx. That is integration of e power x into, here it is, first term 1 by 2 times of cos square x by 2 plus second term 2 gets cancelled, cos x by 2 cos x by 2 gets cancelled. Simply we get tan x by 2. Now integration of e power x. This is 1 by 2 into secant square x by 2 and this is tan x by 2 dx. Suppose that tan x by 2 equal to t. Then you will get half into secant square x by 2, that is its derivative. If it is f, its derivative f dash. We know the standard result. Integration of e power x into f plus f dash of x dx. That is e power x into f of x plus c. Now the solution is e power x into f of x, nothing but e power x into tan x by 2 plus c. You have option C is right answer. Next, we go for another question. Suppose that the question is integration of f of x into cos x dx is given as half into f square of x plus c. Then the value of function of x is option A x, option B 1, option C cos x, option D sin x. Here you have integral f of x into cos x dx equal to half into f square of x plus c. If you differentiate with respect to x on both the sides, then what is happening here? Observe 1 by 2 constant d by dx for f square of x, constant derivative 0. Integration differentiation gets cancelled. You will get f of x into cos x. That should be 1 by 2 into f square of x derivative 2 times of f of x into f dash of x. 2 gets cancelled, and on comparison here f dash of x become cos x, and hence f of x is sin x. When f of x is sin x, automatically its derivative cos x. So the solution is option D in this case. Next, Next question. Integration of cos of root x into dx. This is the question. Options given by first option 2 into root x into sine root x plus cos root x plus c. Option B sine of root x plus c. And option C 2 times of root x into cos of root x minus sine of root x plus c. And option D, none of these. This is the question. You have integration of cos of root x dx. To solve this, let us suppose x equal to t square. When x equal to t square, dx become 2t dt. So here you will get integration of cos of root over x, nothing but root over t square, that is t. Dx become 2t dt. Now you have to apply uv rule. By using highlight, first function u, next function v here. U, integral v dx is integration of cos t sin t minus integration of differentiation of u2 integration of cos sin t dt it is. Therefore, 2t into sin t minus 2 integration of sin t minus cos t, and hence here put plus sign cos t plus c. Now replace t with root x. You will get 2 root x sine of root x 2 into cos of root x plus c. When you take 2 common, root x into sine of root x plus cos of root x plus c it is. Therefore, option A is right answer. Next, we go for another question. The question is integration of e power x into secant x multiplied by 1 plus tan x dx. And here the options are given e power x into secant x plus c. Option B, e power x into secant x into tan x plus c. Option C, just e power x into tan x plus c. And option D, none of these. And here, given integral written as e power x into first secant x into 1 secant x, next plus secant x into tan x into dx. When you write secant x equal to t, or secant x is f, then secant x into tan x written as f dash, its derivative. We know that integration of e power x into f of x plus f dash of x dx is e power x into f of x plus c. So that here you will get e power x into secant x plus c is the answer. Therefore, here option A is correct answer. Next, we go for the another question. Here the question is integration of e power 5 log x minus e power 3 log x whole divided by e power 4 log x minus e power 2 log x dx it is. Options are given. First option e 2 power minus 2x. Option B, e power 3 log x base c. Option C, x cube divided by 3. Next, option D, x square divided by 2. Let us see. It is written as e power log of x power 5 minus e power log of x power 3 divided by e power log of x power 4 minus e power log of x power 2 dx. That is log a power m written as m into log a. And now exponential logarithm gets cancelled. You will get x power 5 minus x power 3 divided by x power 4 minus x square into dx. When you take x common, x power 4 minus x square you will get. So here in the denominator part, x power 4 minus x square. Both gets cancelled. Integral x dx value x square by 2 plus c. And hence option D is right answer. Next. We go for the another question. The question is, integral 2 power 1 by x square divided by x power 3 into dx, which is equal to k into 2 to the power of 1 by x square plus c. Then the value of k equal to option A, 1 by 2 times of log 2. Option B, minus log 2. Option C, minus 2. Option D, minus half. Let us see. To solve this, let us suppose 1 by x square equal to t. That is x power minus 2 equal to t. Minus 2 of x power minus 3 into dx equal to dt. That is 1 by x cube into dx equal to dt by minus 2. That is I equal to integral first 2 power t. Next dx by x cube is dt by minus 2. Therefore, minus 1 by 2 outside, 2 power t integration 2 power t divided by log 2 plus c. And hence, minus 1 by 2 log 2, which is constant, and multiplied by 2 power t. T is nothing but 1 by x square plus c. This is the value of k. And here, the constant is, here it should be minus sign. Then only this is correct. Option A is right answer in this case. Next, we go for another question. Integral e power 4 times of log x. Next, x to the power of 5 plus 1 whole power minus 1 into dx. This is the question. Here you can write this as integral e power log of x to the power of 4. Next, this is 1 by x power 5 plus 1 into dx. Therefore, integral x power 4 1 by x power 5 plus 1 into dx. Now, you have x power 4 by x power 5 plus 1 into dx. To integrate this, let us suppose that If you divide with x power 4 by x power 5 plus 1, you have here. And the integration of this, assume that x power 5 plus 1, suppose d. Then 5 times of x power 4 into dx become dt. And x power 4 dx is dt divided by 5. And x power 5 plus 1 is t. 1 by 5 outside. 1 by t integration log modulus t plus c. Therefore, it become 1 by 5 log of t is nothing but x power 5 plus 1 plus c. So this is the right answer. We will discuss another question. Suppose that integral dx by 1 plus tan x. This is the question. Options are given. Log modulus secant x plus tan x. Option B, 2 times of secant square x by 2. Next, option C, log of x plus sin x. Option D, 1 by 2 of x plus log of mod sin x plus cos x plus c. This is the question. We know that it can be written as integral cos x divided by cos x plus sin x into dx. Right? Now, cos x by cos x plus sin x. Numerator, you have to select a into differentiation of denominator plus b into denominator. This is the working rule for these type of questions. Just by writing tan x as sin x by cos x, you will get cos x by cos x plus sin x. Numerator here cos x, and it can be written as a into differentiation of denominator part, cos x derivative minus sin x, and sin x derivative you will get cos x, then plus b into denominator, that is cos x plus sin x. Now, comparing cos x terms, cos x coefficients, you will get a plus b, which is equal to 1. And comparing sin x terms, minus a plus b, which is 0. And hence, a equal to b. Therefore, a equal to b means a of b of gives 1. Therefore, the value of a 1 by 2, the value of b 1 by 2. And for which the working rule, integral, numerator written as a into nothing but 1 by 2 into differentiation of denominator plus b, that is half, into denominator whole divided by denominator dx. Numerator half into derivative of denominator plus half into denominator. So here f dash x by f of x first term. Therefore, f dash x by f of x is log modulus denominator part. Next, denominator gets cancelled. Of x plus c. Therefore, you will get half into log of half, if you take common, log of denominator part is cos x plus sin x and x plus c. Therefore, from the given options, it is very clear that option D is half of x plus log of sin x plus cos x plus c. And the remaining options are not correct. Thank you, Ananda. We will discuss definite integration topic in the next session. Thank you.